In the 13th example, we can create the complex class, just like in the math, okay? So this init function is given in here, and real is the real part of this complex number, and imag is the imaginary part of this complex number, okay? And so we assign to the what equal to the 0. This is a default argument, okay? Just like in the previous examples. And so the self real is assigned with the real, and self imag is assigned to imag, okay? But just remember that this real is the argument real, this imag is the argument imag, but this self imag and self real possessed with the what? With the class variable, okay? And so the def disp self assigned with the what? The print empty space plus empty space I dot format self real and self imag, okay? So z1 complex can be defined just like this one. Z1 disp is calling right now, okay? And so what is the output of this code? What is the output of this code? Yes, 0 and 0, because the default arguments gives us this property. So Z2, the complex 10. What is the output of this code? Yes, 10 and 0. And what is the output of this code? 20 Z3. See, we can create what the default arguments in the what? In the constructor. And we can use this property in the what? In our own build the complex class, okay? But the Python possesses the what? The default complex class. Just remember that. X14. So in the X14 we will look at the class attributes and object attributes, or the instance attributes that we have talked about in the previous examples, okay? And so we can build the what? The class student in here, and X10, and the print X is calling in here. This X10 is the what? The class attributes. Class possess this variable, okay? Not the object one. And also this is the class attributes, not the object one. And def init self name and no can be given in here. Self name name self no is equals to the no, okay? And def disp self print name and no dot format self name self no, okay? And also print X is equals to the what? The format. And how we can call the X? Just see that. If we write the X, we have the error in here. See? This X cannot be built with the what? With this property, but X is not defined in this function body, okay? But the disp is not called by the function, and so even if this is an error, we cannot see it right now, okay? But if I create the as student, just like this one, Mehmet, İşcan, and 1, 2, 3 are the our name, and so just see the 10 is seen already in here, but as disp is called in here, and so the name x is not defined in here. How we can call the what the x right now? In order to reach the class attributes, we can call the what the student x properties in here, because the student possessed the what in the class attributes with the values of the 10 as a name with the x, right? And so student x can be called in here by using the what the class name of these terms. Okay? So how we can reach the what the x value? Just in the similar way, we can call the what the student x in here, and so we can build the class with the specific variables or attributes or the definition to call the what the just using the name of this term student.x, right? But this x possessed with the class, not the instance one or the objects one. You need to understand that. Okay? So, in the 15 examples, we will continue with the what the class complex. Def init self real 0 imag 0. Okay, and self real is created with the real, self imag is created with the imag. Okay, and also we can build the def disp with the self keywords, the print, this one, and the fancy parentheses I, and we can say that the format of these terms is self real, self imag. Okay, so we have the only one another function in here, the self and z value in here. The result is built with the what, with the complex class, and so we can use the initialize values of this value or the complex function method in the what, in the class objects, which is called to the what, the init function, guys. Okay, this is the constructor, and so the result real can be assigned with what, the self real plus z real, because we have possessed the real body in here, and also z is a parameter of the another complex class in here, and also the result imag is assigned with what, the self imag plus z imag. Okay, and also we can return to the what, the result value in here. Okay, and so if I run this code, we will now error in here. Okay, and so the z1 complex 10 and 20 can be created, and also z2 complex can be built 3 and 4 in here, just like this one. This is the z2, and also we can create the z3 z1 at z2. See, this z is built with the what, with the z2, which is the instance of the complex values, and so the z1 possessed the self real and self imag with the values of the 10 and 20. Okay, and so z is possessed with what, the z real is equals to the 3, z imag is equals to what, is equals to the 4, and so z3 can be created in here just like this one. Okay, and so z1 disp z2 disp and z3 disp. See, 10 20 3 4 and 13 plus 20i is seen on this page. Okay, any question about these terms? If there is no question, and then I will ask another question. How many times the complex constructor are seen on the terminal page if I run this code? How many times? We have z1, z2, 2 function, but z3 is also called the complex body. Okay? And so, if I run this code, just see that the complex constructor, and the complex constructor are seen on this page. But z1 and z2, okay, but where does it come from, the z3? Or the third complex constructor is generated from where? Yara or Mustafa? Just see that this add function, yes, the result is given here. So what about this one? If I call 2 times this value, what happened? How many times the constructor can be called in here? If I run this code, we have the 4 constructor in here, because the add is generate or uses the init function or the complex function body. This is called in here, just like this one. But what about I turned into the z3 equals to the z3. Just now the add z3 is add parameter up to z1. How many times the constructor called right now? See, if we have this property, just see that we have the 4 times in here, but in this case we have the 5 times. Okay, because at each case one constructor is called in here. Okay, but in this case we have 1 and 2 in here, 3, 4 and 5, even if the z3 is defined in the previous page. At each case this complex is reinitialize whole the values or recreates the variable of these terms. But just see that the number of these terms 23 plus 44. The number is increased with the basis of the addition of these terms. Okay, or we can call it just like this one. Can pass these arguments also in here, right? If I run this code, and then we will have 1, 2, 3, 4, 5 and 6. Why 6? The last number are the same. Why is it is 6? 6 times call the constructor right now. Can anyone say the reason of these terms? See, if we call the add function, and so we generate the new init function in here, okay? And so 1, 2, 3, and also we call the another add function in here, which means that we have 4 add and 2 constructor, and so we have the 6 complex constructor in here, guys. Okay, this is why we call 6 times complex constructor. Okay, so in this example, the class sample x is equals to the 10. Okay, and also we can print the sample x. What is the output of this code? What is the output of this code? Yes, and this is 10. And after that, the sample x is assigned to 20 and sample x is recalled. Just see that the x is updated with the 20 value. Okay, but what about this one? Class sample x is equals to the 10. Okay, and so as sample is called right now, and the print as x. What is the values of the last term right now? Yes, see, this is the 10 because the class sample overrides the before implementation. Okay, but what is the output of this code? Sample x. What is the output of this code right now? What is it? Yes, this is also 10, and we can say that we can also reach it using class object, not the class one. Okay, what happens if I as x is equals to the 30? What happens if I run this code right now? See, in this case, the x is seen to what? To the 10 at the last case. Can comment this line in order to see easily. 10 and 10 is seen on this page, but why? Can anyone say that? Yes, Yara, thank you. X is only updated with this property, okay, not the other one. We can reach the proper x value, but the sx has its own property. This is the instance attributes, not the class one, but we can reach the total generated class one values in here. And so what happens if I run this code sx? See, this is the 10, this is the 30. Right now, do you understand what is the difference between the instance and the class attributes right now? Do you understand that? That's a good question. Why do we use the instance attributes? If we have the instance attributes, for example, if we have the student class, and so if we have the 50 students in a class, but these students have the different names, Yara, right? And so these instant attributes collects to the what? To the different name. This is why we are using this value, not the class attributes. We can specialize at each class instance or class variables to the what? To the specific student. Otherwise, we cannot write the each student in this class, because this X is a common property. The other ones is a not. Okay? Do you understand that? If we want to define the 50 different students, we can use the class student, and each class instance has or have a different names or no, but not the class attributes. Do you get it? Okay. Class sample x is equals to the 10 def init self and x. Self x is equals to the x. S sample 20 and print sx. What is the output of this code? No, it contains only one value. Lion. It's the 20, because the sample has possessed what its own self property, self x, is called in here. Okay, but what if the values of these terms, sample x, okay, 20 and 10. Did you understand right now the difference between the class attribute and the instance attribute, guys? So, in this case, we will continue with the addresses of classes. Okay, this is our topic. So, in Python, it is just a statement. Which statement? It's a class, okay? And so, if the class is interpreted from Python compiler, first of all, it's creating the type class objects, just like in the previous example. Just remember that if we build the sample class, and so we can call the type sample, and then this is the class of the type. But after that, each elements defined in the class are stored for the class which you define. Just remember the previous examples. And also, therefore, the class name just keep the addresses of the type object. You see? But this is just the sentences. How we can prove these properties? First of all, the class sample def foo self can be built with these terms, and so print foo is given, and so the print type of the sample. What's the output of this code right now? What is the output of this code? Yes, class type. Because this type is given creating the type class object. This is also another object, but it's a general object that we can create the sample objects in here. Okay, so if this is the case, we should give the what x2, so it is just an address. We can add another variable or function to this class after class is created, because we can add the variables and also we can add the function or the methods, because class only contains the address values of these terms, just like in the other Python properties. Okay, for example, the class sample def foo self print foo, right? And also we can build a def b self print bar. Okay, and sample b can be assigned, or the bar is assigned with the b. What happens if I run this code? If I run this code, there is no error, guys. Just see that, because this is the new method for sample class, because it's just an address. And also this sample is an address that keeps address just like the any other Python properties. Okay, and so s can be built with the what, with the sample as few, and s bar also can be called in here. See, do you understand that these properties, the sample contains both the b function and the foo function, because the sample is just an address, and so this address can keep another address in the Python, and so we can assign any b variable in here, just like this one. Yara, did you get it, every properties of this utilization? What happens if I remove this self keyword in here? See, b takes the 0 positional argument, but 1 was given in here, because this bar contains always, must always possess what, the self keyword, and so this is the error. Okay, but this is current. There's no syntax error in here. Okay, just remember that. If we assigned any function or the variable to the class, and so we should always utilize the self keyword, otherwise we cannot use it. In the text example 3, class sample can be built. Def foo self print foo. Okay, so s equals to what, the sample, and print type of the sample, right? If I run this code, and then the class of type is given, because the sample is the another instance of the type. But what about this one, type s? What's the out of this code? Just remember that this is the main sample class. Okay, s main sample type, but this is the standard type. Okay, you get it? And we can conclude that if this is the properties, and so we can write this property, thus class is only represented by data structure that can perform some tasks on the common variables which class possess. Okay, that's all. This is the class, nothing more. And so if this is the case, and then we can build with the what, with the another properties, the important properties of the object oriented programming language. This is the composition. Okay, what is the composition? A composition, a class object, is included in the other class. This is called the composition. Then this is called composition. Okay, it's just simple. This is a keyword name in Python. Has a. Okay, this is the has a property, and you can see that an object composed by a class is only related into one object, and the runtime life for these objects within a class are almost the same with the another one. Okay, but how we can prove that? If this is too complex to understand these things, and so we can build the example in here. Def init self, and so the print, this is a constructor. Okay, and we can say the pass, and also we can build the another properties is the pass and class B. Okay, def init self, and the self A is initialized with the A. Print, this is B constructor, and the pass. So if I run this code, there's no syntax error in here, but what happens if I create the B object just like this one? What is the output of this code? What is the output of this code, guys? Yes, this is a B constructor, but we have add more one properties, because just see that this is a constructor and this is a B constructor, because if we call the B, and so this init function is run on the runtime. Okay, and so but this init function contains the what the self.a is equals to the A function method. This is the A constructor, right, Mustafa? And so this A must be created with the what? With this constructor. And so this gives us to what? This is a constructor, because the A is also created in here. And this is B constructor, because this B is also created in here. Okay? No, it's assigning to this one, but this is the new instance. New instance is created in here because we called what? The constructor of the A. Okay, and so this constructor of A is assigned with what? The self of A. Okay, for example, if I choose the what? Def disp self print A function can be seen in here, and so B, A, and this can be reachable just like this one, guys. If I run this code, this is a constructor, this is a B constructor, and A function is seen in here because the B possess the what? The A class instance, which means that we have composition in here. Okay, do you understand what is composition in Python, guys? Yara, Mustafa? Okay, And so in the sixth example, we will create a more complex formula for these things. Class square pass, okay, and class board is in here, and so def init body self squares is equals to what? Non-value times 8 for I in range 8, okay. And so if this is the case, we can give the pass and board is equals to the board, okay. And so if I run this code, there's no syntax error in here, okay. But is there any composition in here or not? Yes, Mustafa. Your question is the what the self A is created with what A, and so this A creates the new instance in here, okay, and so the whole the contents can be reachable by using this instance value, Mustafa. But in the second question, this square and board are in the relation of the composition or not? Could you tell me? Yes. No, because there's any utilization about what a square form in here, okay. No composition in here. We have also another properties in Python. Aggregation. A class object has another class object, just like in the composition, but the lifetime may be different. This is a special keyword with a holds a relation, okay. For example, class A pass can be given in here, and so class B and def init, just like this one. And also we can set the what the A is none, okay, and self A is A. We can write def set A self, and A can be given in here, self A is A, okay. What happens if I run this code, class A? We can write this code, and so this is not a relation, but B1 is equals to the B constructor. What happens if I run this code right now? If I run this code, there is no syntax error. And what happens if I create this one, B2? There's no syntax error in here. And set A, and B2 set A. See, this A is to what is created with this one, but self A and self A are different in here because the one of them is a class of A. The other thing is that the self A is an instance of A, okay. And so if I run this code, there's no in here, but the one A object is used right now by to another B object. See, and so if we terminate the B2 or B1 at the different times, The lifetime may be different. This is a relation of the holds a. Okay? Okay? Did you understand that? If you don't understand, we will create another example in here. I just remembered this example, but after the break. Okay?